Then we're nearing the end of this video, and there's a couple of things we have left to do. First of all, we need to add a weight to the item. So this needs to have a certain weight, and the weight should slow down the player, the walk speed of the player. And we should be able to place these items on top of the pressure plate, and if the weight is sufficient, the pressure plate should go down and open the door. That's the entire setup. So we can start off by adding the weight and making the player go slower when carrying a heavier item. Now, first of all, actually, when it comes to weight, if you just add a mesh to the world, just add anything to the level, any kind of static mesh, for example, this thing here, and then if you were to look in the detail panel, it would say mass in kilograms. So it's currently 385 in kilograms, apparently very heavy. That mass is calculated by the size of the object. So if you were to make the object smaller, so I'm gonna just scale it here, then the mass is smaller as well. So the mass is simply calculated based on the size of the bounding box of the object. There's also a value over here that says mass scale. Changing that number will change the mass in kilograms, because you can't edit it here, but you can use the mass scale. As you can see, now it's 126 to change it over there. You could use this. You could actually, for example, I can show you in the level blueprint, I have the object selected. You could then do add reference to the object you want to get the mass from and look for mass. You get the mass, and this number is the same as the number over here. So we could be doing that for the item we have, but I actually prefer to have my own variable instead. So I'm gonna disregard the mass value, and I'm gonna go with my own value instead. So in the item, this is the item to pick up. I'm gonna make a new variable. I'm gonna call it I can call it mass, actually. Mass of item. I'll make it a float. And actually I'll expose it so you can edit it in the level. You can see if I were to compile this now, look at the stone. It would now say mass of item is 0. So that's a default value of 0. Let's say we don't want a default value, because you can set the default values of these things, of the variables in here. If you were to look at the bottom of the details panel, it would say the default value of mass of item. So let's say that by default it's 2 kilograms or 2 whatever you want to call it. And then what you can do is you can, when the player picks up the item, it needs to get the mass from the item, and depending on how much that value is, the walk speed should be reduced. Or for example, you can set other things as well. If you are in the player and you go to components and you look at character movements, then here you have most of the standard settings that control the player. So you can see the acceleration of the player, the friction on the ground, so lowering this number would make it more like ice, max walk and fly speed, the jump, how high you can jump, and so on. So what we want to do is we want to change the speed of the player when you pick up an item. So this is where we pick up the item and so on. What we can then do is we can take item you hold and get the mass from that. Get mass from item. So now I've extracted that number, and then you can set that to the speed of the player. What you need to do is you need to change the character movements ground speed, max walk speed. So in order to do that, we first need to get the character movement over here, and actually would look like this for you. So in the list of variables on the left, look for character movement. However, that probably doesn't show up because it's a pre-made component. So therefore, tick the box at the bottom saying show inherited variables, and then you will find character movement. So get that, and then from there you do set ground speed, or rather set walk speed, I believe it is. Set max walk speed. Max walk speed right now is by default 400. So let's actually take 400 and divide the 400 by this. So if the weight of the item is 2, 400 is reduced to 200. Therefore you begin to walk slower. Therefore the heavier the object, the slower you walk. So you can start from mass of item and then do divide, float divided by float. And actually it should be there. First value should be 400 because 400 is our standard value for the speed. And we connect that there. And likewise for when you drop the item, it should simply set the speed back to 400. That's it. So let's see if that works. And actually let's just duplicate the rock here. So I have 2 rocks. And let's set the value, the mass of item for the other rock to 8 and see if that one makes you walk slower than the first one. So I am walking slower. You can see if I drop the rock it goes much faster, and if I pick up this one I walk really quite slow. In the exact same way you could have added other benefits to it. For example, you could have set the jump value, sorry, wrong one, from character component. For example, you can set jump set velocity, and you could say that when you pick up an item you can jump higher. So basically any value you have in character movement you can change depending on what you're carrying. You could see if I jump now, I jump this high, I pick up a rock and I jump this high. Also things can be cleaned up a bit here. You can make comment boxes like I have for the other things, which might be a good idea. So I'm gonna move it out a bit. And then I'll select everything you want to combine in the box, right click, create comment from selection, and I'll call it tutorial. Next up, we need to be able to make sure that the pressure plate understands the weight of the item as well. To do so, we're going to have to change the pressure plate quite a bit. So what we have right now is we have the 2 triggers here for begin overlap and end overlap, and then they trigger the matinee, or the timeline rather, sorry, which will update the position of the pressure plate. What we have to do here is disconnect these 2, and we're actually going to connect the timeline to a tick event. So I'm moving it down here, and instead we add event tick. And what we then add is we then need to know how much weight there is on the pressure plates. What we're actually setting up here is we're continuously checking, the tick will continuously run, it continuously checks the weight on the plate, and if the weight is over a certain value, then the timeline will play. If it's under a certain value, the timeline will reverse. So in other words, we need to know how much weight there is on the plate. Therefore, we're going to have a variable that represents that weight. So on the left side, I'm going to make a new variable, create variable. I'm going to call it weight on plate, or whatever you want to call it. It should be a float. There we go, and I'll drag that in. So get, and then you want to check how much this is. So you want to compare it. So I'm going to drag from here, I'm going to look for compare float. So continuously on every tick it will check the weight, and if the weight is over, let's say 10, so let's say 10 is the amount of weight needed to trigger the pressure plate. If this is larger than 10, it will play. But if it's equal to, or actually let's connect equal to as well, but if it's lower than that, it will reverse. So this works already, this is all we have to do over here. But of course we still have to figure out what the actual weight on the plate is. So this variable, it will be set somewhere else. It won't be set over here, but it will be set here based on these boxes. I'm going to temporarily disconnect these 2 as well. We'll figure that out later on. Let's first focus on the actual weight. So as it is right now, if I were to step on the pressure plate, it would not go down. So first of all, I'm going to make sure that the player itself has a certain weight before we do the item. And I'm simply going to say that the player is always 10. So if the player steps onto the pressure plate will always go down. Therefore, I would say set weight on plate and set it to 10. If you go off the plate, so end overlap, it sets it to 0. Therefore, this will work. Because when I step onto it, the variable becomes 10. You can see here, it continuously executes this. And you can see that the current value is 10, so it works. That doesn't cover the item, however. It might actually work with the item as it is, but it's not really the way to go. So it might work, or not even that. It's probably the wrong trigger type. So what we have to do now is make sure that, first of all, the trigger has to be able to understand that the item goes on top of it, and then it has to add the weight of the item to this variable. So first of all, let's check the trigger. The trigger used for pressure, we previously set that to overlap all dynamics, so actually that appears to be working. So let's see if the trigger actually is able to detect the item at all. I'm actually going to play and just run the window alongside it and see what it does. That does appear to be working, so it was just a small bug earlier on. So the stone is on top of it and the pressure plate is down. So the trigger correctly understands the stone. That's good. So what we can do then, and this is not the entire setup, but it's a start. We can get the other actor, because the other actor is whatever is triggering it, which could be the player or it could be the stone. And we can say that if this is the player, so what we do is we compare this, or rather we do equal. If this object is equal to another object, the other object being the player, so get player pawn. So if the one who triggers it, the instigator, is the player, then we add a branch, so hold the B key and press somewhere. Then we set, if true, then we set the weight to be 10. If false, however, then we get the other actor, and then it clearly is an item, so then we cast it to item to pick up, because the engine has to understand it's this type of actor or blueprint. And then we get from the item the weight, or I think I called it mass of item actually, get mass of item, and then weight on plate becomes equal to mass of item. So now I have this, and then the other one would be the opposite of this, so I can quickly set that up as well. Or actually we can just keep it on 0. Works fine. Again, this is not waterproof, it's the first step, but it should at least work. So now the thing should recognize the weight of the item. Now remember, it needs 10. So one stone we have over here, one rock, is mass 2 or weight 2. The other one is 8. So let's actually make the other one 10 to see if it correctly goes down if that one is on top of it. So first of all, the player still makes it go down. So that works. Then we have the lighter rock. That doesn't do anything. And then we have the heavier rock, which makes me walk very slow. That's half of it. That's half on top, but it already makes it go down. So that works. But of course there is a problem if you were to do this. If you were to set the weight from this one to 5 and the other one to 5 as well. What we then want to accomplish is that we have to put both stones on top in order for the pressure plate to go down. And that doesn't work right now. It doesn't add up. What he needs to do is add up all the weights of all the objects on top of it. So in order for us to be able to accomplish that, what we're going to do is we're not just going to set the weight directly. We're going to get the weight on the plate as it is. So we first get it, and then we add something to it. So I do float plus float, and I add 10 to it. So if it's the player, I take whatever weight is on it plus 10, because the player steps on top of it as well. And that becomes the new weight on plate. And similarly for the item, if the item is added on top, I will get the current weight on the plate plus the weight of the item, and that then becomes the weight on the plate as it is. And then I need to do the opposite over here. So I need to get the weight on the plate. Actually, let me just duplicate this whole thing. But rather than adding it, I subtract it. So float minus float with the same value. So the player represents 10 and the item represents whatever mass it has. This way it will always add up and subtract from it. So you can actually put multiple items on top until it reaches a certain number. The weight on plate is going to keep adding up because it will keep on doing this every time something else is added on top of it. So therefore the number keeps going up. So let's try. First of all, the player stepping on top of it still works. Then we got 2 stones here with weight 5. That's 1. And here is number 2. And you can see now 2 stones are on top of it and the pressure plate goes down. If we were to look in blueprint, we can see that the weight on plate is current value 10. So it works. If I were to step onto it myself as well, weight on plate is actually 25. I actually didn't seem to subtract away from it, so I might have made a mistake somewhere here. But it's adding up correctly. Yes, I didn't connect this one, so that caused an issue there. But the system works otherwise. Let's quickly try again just to verify it's correct. Or actually it does work correctly. I probably spawned on top of it the first time. In any case, it seems to work now. And also what you can do when you're confronted with situations where it doesn't work, in Blueprint you can always right click any variable, for example this one, and do watch this value. That will output a number above it, so I can easily read the number all the time while I'm playing. So I can then play while looking at the number. So the current weight is correctly detected as 0. I step on top of it, is correctly detected as 10. I take a stone, I dump that on top of it, it's 5 indeed. I step onto it myself as well, so it becomes 15 and it goes down. I take the second stone, it's now 10, goes down. I step onto it, it's 20, so everything appears to work. And I can even step onto the plate while holding a stone. So I'm holding the stone while stepping onto it, and it becomes 20 as well, which is correct because it's 10 for me plus 5 for the stone. So this now appears to work. Then the only thing left to do is to connect the door, connect the pressure plate back to the door, so that by putting the 2 stones onto the pressure plate, the door opens and we can leave the room. So we have the 2 remote events again, the event dispatches here, where we can connect that to. We can't really connect it here though, because this just handles the weight, so we're going to have to be able to connect it somewhere here. And then the problem is, we can't really do this either. We can't do finished on the pressure plate, because finished also means reverse. So finished is both meaning it's done playing, it also means it's done reversing. So it's both finished and reversed, which can be a little bit confusing. So this doesn't work. What we need to do is we need to know the direction. So what we can do is this is an enumeration. We can get the direction. There's other ways of doing this as well, but the direction works, for example. And in here we can look for timeline direction, switch on E timeline direction, and then you have the ability to see if it's forward or backward. So then I can say if forward, it means the pressure plate is down. If backwards, it means the pressure plate is up. Another way of doing something like that, it would be to get the timeline in here, because every timeline you make in the graph also shows up as a variable on the left. So this one represents that. Therefore, if you would be wondering about this, you can, for example, set the play rate. Set play rate. Or you could, for example, force it to play. So this one is the same as triggering play over there. And because of that, you can also do other things. So for example, playback position, I believe, or yes, get playback position. That would give me a number where it's located, and then I can use that number to figure out whether it's reversed or completed. Okay, so I'm going to connect this there. Place it somewhere underneath or above, perhaps, doesn't really matter. And then let's see if that works. That appears to be working. I step onto the pressure plate, and when the pressure plate is all the way down, the doors will open. But when I step back off it, the doors will close again. So in order to complete this small little environment puzzle, I will put these two stones on top. And the door will remain open, allowing me to leave. That brings us to the end of this The Solus project blueprint introduction video. My blueprint continued video continues on this one through the creation of a damage and response system, inventory and item crafting. I hope you learned a lot from this, and thank you for having purchased my work.